Alrighty, now we're going to make the second part of the surface area formula. So we need to start off with an obvious distraction, my dog. All right, so here we go. One more look at Gracie. She was laying on my notebook for a minute, so I had to move the notebook. All right, what I want to point out is that the radii, when we're thinking about the radii on that frustrum, so here's our frustrum, that's that piece. This is the radius of the big part, and this is the radius of the small part, or vice versa. But you're taking your two radii, and they're actually going to be our function values. So it's going to be our function value at the x sub I minus 1, which is the leftmost, and then the f of x sub I. And so that'll be the rightmost of those. Okay, so we're going to grab our formula that we had. We had s is equal to pi times the radius of the big plus the radius of the small times the length of that frustrum. Now we know the length of the frustrum by the Pythagorean theorem is going to be the change in the x squared plus the change in the yi squared. And this is going to act like that arc length issue that we had previously. The radius of the big base is going to be our f of x sub I minus 1. The radius of our small one is going to be our f of x sub I. Depending on how the shape goes, you can have those flip-flopped. It isn't a big deal because what's going to end up happening later is we're going to find an average of these. And so we're just averaging them out to find an overall radius. Anyhow, we did what we did in the arc length problem, where we factored out a delta x squared, factored out a delta x squared, and then when we took the square root of the delta x squared, we ended up with just a plain delta x, and that will be our dx. We have the square root of 1 plus delta yi over delta x, that's squared, so that's going to be our derivative of our function. Now, we have kind of this cool component going on right here. That's referring to the intermediate value theorem. So the intermediate value theorem basically says that there exists some x in between our x sub I minus 1 and our x sub I. So somewhere on that interval is an x such that our function value is going to be equal to 1/2 the function value on the left plus the function value on the right. Now, we don't have a 2 in here yet, but this is where the 2 is going to come from. We're going to multiply both sides of this equation by 2. So we're going to have 2 times that special value that's generated by the x that's in that interval, and that is going to be equal to those two being summed up. So we're going to have that 2 getting out in front, and so we're going to have 2 times f sub x sub I star star, meaning it's the special x sub I, where our function value is the halfway between the two. This is just that rewritten and squished because I ran out of space. So this is going to be our 2 and our radius. So this 2 is that 2, and this f sub xi, or f of x sub I star star, that's going to end up being our radius. This piece will end up being our delta x. Okay, so all of this is going to come down, and what we're going to do is the surface area is approximately equal to the sum, and we're heading towards that idea of the Riemann sum. So all of this is going to fit in here. We're going to apply the limit, and when we apply the limit, our delta x will become dx. And when we apply the limit, the f sub x sub I star just becomes f of x. Okay? Now, again, that f of x is going to be our radius. This piece is going to be the length of the piece that we're swinging around. Okay? It really works out that this 2 pi r is really the circle. We're taking that frustrum and we're swinging it around the circle. Okay? All right. I hope that helps in terms of the derivation of the formula. You have a good one.